Today we're going to be working with multiplying and dividing rational expressions. I'm going to be just doing these odd problems, so you have it here. And I'm going to be showing the answer key right now. And there you go. So let's take a look at how to simplify each expression. So when you see a polynomial, the first thing you want to do is factor. So you notice the right-hand side, because they're just binomials, we can't really factor too much in this sense. However, let's take a look at above and below and see if we can get to factoring. So the top is a perfect square. So difference of squares. There are two, so it's a binomial. They're both perfect squares and they're separated by a subtraction sign. And if we were to write the perfect square of 36, that would be 6 squared. So we can write 2 of everything. And these will be going into your parentheses here. And how to cancel out your middle term, because it's a binomial, we're going to alternate your signs here. Again, check to FOIL. Now your other one, we have we have 48 minus 2k minus k squared. The first thing we would want to do when factoring one like this is to reorder it in descended order from the highest power to the lowest power. Now, before we get to factoring, we have a negative leading coefficient, which is very difficult to factor. So let's go ahead and factor out your negative first and change all of your signs in the middle, or all of your signs on the inside. So now we can figure out, well, what are some factors of 48? Well, we have 1 and 48. You have 2 and 24. You have 3 and 16. Let's see, you have 4 and 12. Let's see, if 5 won't work, 6. We have 6 and 8. And once you find your factors, because what we're doing when we're doing a simple factoring like this, so you check for GCF, you check for any sort of negative leading coefficient that you want to throw out of there. It's simple factoring because your leading coefficient here is 1. If it's -1, as you've seen, you're going to toss that out. Now we're going to be looking at your middle term here being +2. And of your factors, 6 and 8 can make a 2. We're trying to make a +2, which means 8 has to be positive and 6 has to be negative. There's only 2 ways to make it, there's only 4 ways to make it work with your signs. They can both be adding. They can both be subtracting. They can alternate their signs. And you're just going to be kind of doing a trial and error to get this +2. We always want to multiply back with your signs to just double check that we'll still get a -48, which we do. So this is our your factor. So we have -6 and k plus 8. I'm going to scooch this over a little bit. So now we have times k plus 8, and we'll put that into parentheses, and k minus 3. Now of these, right, what looks the same in your parentheses? So we have a k plus 8 that can cancel and simplify, and we have a k minus 6. So we're left with k plus 6 over k minus 3. Now these k's cannot cancel, much like what we did in class. We said, well, even if you have 10 over 10 plus 2, these 10s won't cancel because 10 plus 2 has to happen first. You have to add them to create 12, that number. X, or in this version, k, is going to signify a number. So you can't just cancel it out because k minus 3 and k plus 6 will create something new. So if you're tempted to cancel out, just put it into parentheses. Only the same parentheses will cause us to cancel. Now let's try it again. Now, unfortunately, nothing here can simplify as is. So instead, when you have a division sign, we are going to do the keep, change, flip. You're going to keep the same sign. So if it's positive, it's positive. If it's negative, it's negative. you're going to change the operation. So instead of division, you're going to multiply, and you're always going to flip this fraction upside down. So instead of x plus 7 over 4x, it's now 4x over x plus 7. Now we can go ahead and simplify. Well, you'll notice that directly across, they both have a 4x. And if you wanted to as well, you can simplify the 16 and the 4 here and one of your two x's. So it doesn't always have to be directly across. You can look up and down. Same thing here. We looked up and down and across. So we're left with 16x squared over x plus 7. Any sort of parentheses down below. This is a binomial, so these x's cannot cancel as is. Now let's try it again. You'll notice that on this one, on the left-hand side, there's nothing really to simplify. However, on the right-hand side, both have an 8 in common and both have an m in common. So we're going to factor out an 8m, leaving behind m plus 7. And down below, we're looking at factors of 42. So factors of 42, we can list them all out other than 1 and 42. 2 and 21. 42 divided by 3 doesn't work, should be 14. There we go. So that's close. 14 is kind of close to 13, so we're getting there. 42 divided by 4, that doesn't work. 42 divided by 6, that should be 7. And we're trying to look for, of these factors, what can get us to 13? Well, 6 plus 7 will work to get us a 13, and a positive 13 at that, if we add them both together. And when you multiply them back together, they will get you to a positive 42. So we're left with m plus 6 and m plus 7. Now, as far as canceling goes, now that everything is factored, we can then go ahead and cancel your m plus 7. So we have 8m over m minus 1 and m plus 6. And you'll notice at no point in time throughout our first 3 problems are we ever multiplying your expressions. So you'll notice that we didn't actually go ahead and multiply these here. Same thing down below or over here. Even at the end, we're not going to multiply your final product down here. We want to keep this in factored form. In other words, do not multiply. So let's try it again. So again, your left-hand side, we can't factor it too much other than putting in parentheses. We're going to divide by, your numerator can't simplify any further, and minus 7, if you want, you can put it into parentheses. But we do have your trinomial, which we can factor. So factors of 35, 1 and 35, 5 and 7. So 5 and 7 can get you to a negative 2 if and only if we subtract the 7 and we add the 5. So the bigger number always gets the sign, little tidbit. And because it's simple factoring, we can just put it right into the expression. Now you can cancel here, but again, I want to make some really good habits. You factor first, and then you want to flip, because sometimes you might just cancel and be like, you're all done. No, with your division, you want to keep change flip. You're going to keep change flip the one on the right. So you have n plus 5, n minus 7 over n minus 7. Then we can go ahead and cancel. And your final end product is n plus 5 over n plus 4. Putting them into parentheses, your n's do not cancel. So keep in mind, division, it doesn't matter if you decide to flip it first and then factor, or factor and then flip. As long as those two processes are happening, it doesn't matter. All right, we'll do it again over here. On your numerator, you both have a 6 in common, so we can take that out. X minus 1 is left behind. And on the bottom, it looks like we have a negative leading coefficient. So if we were to rewrite the bottom, we should have negative x plus 5. Now with a negative leading coefficient, we don't like that. So instead, we're going to factor out the negative and change your signs. Then we can go ahead. Since this isn't really factorable, we're just going to do a keep, change, flip. So let's flip everything. X minus 5 and an x minus 1. We can go ahead and cancel. We're left with 6 over negative 1, or if you prefer, just negative 6. I'm going to try it again here. B minus 8 over B minus 4 divided by 6B over. They both have a 6 in common and a B, leaving behind a B minus, let's see, 4. And if you don't know how I'm factoring, please go back and see some of those factoring videos. So let's go ahead and keep, change, flip before we cancel. If you wanted, you could put these all into parentheses. We're going to flip everything. 6B, B minus 4, and 6B over here. And then we can go ahead and cancel. We're left with B minus 8. All right, if you wanted to, you can go ahead and cancel these ones out. Otherwise, we can still factor first, which good habits. I'm going to show just factoring everything. Let's see, 8n squared. Now down below, you have a 6 in common and 2 n's. So at the very end, we should have 1 left over n plus 8. So canceling out your terms here, we're left with n minus 1 over 6n squared n plus 8. I think this is our last one. All right, factoring out a 4, we're left with 7k plus 1 over 2k divided by, factoring out a 2k, so 7k plus 1 placeholder, 2k. We're going to keep, change, flip the rightmost term. That one's doing the dividing. We're going to cancel, cancel, and you can only cancel one of these 2k's. So whether you cancel it across or up and down, it does not matter. But you can only do 1 for 1. So we're left with 4 over 2k, which that can cancel in itself. So 4 divided by 2 is going to be a 2 on top and k on the bottom. So this 2 will cancel with one of the 2 in the 4. And there you go. Again, answer key over here. Hopefully they all come out correctly, which it looks like they do. As long as I didn't forget our negative. Oh, I did forget our negative. Just by looking at your answer key, do you notice that I left off this negative when we went ahead and did that? So we definitely want to add that part back. My apologies. Notice how easy it is to make a mistake here when you factor out some GCF. Hopefully I'm not missing anything else. Let me compare now. I'm a little nervous. That one looks good. All right, the remaining look good. All right, so hopefully that gives you an advantage with your multiplying and dividing rational expressions.